All right, Coreq was some material, lesson number 7, final lesson. Not to get all dramatic with you here, but I think this is one of the most important review sessions that we have because being able to carry out problems on regression and correlation, it's important to revisit linear functions. So the first question pertains to finding the slope of a line that passes through 2 points. Just to jog your memory a little bit, the slope formula is y2 minus y1 over x2 minus x1. So what I just let the first order pair be, x1, y1, and the second ordered pair be x2, y2. And I think it helps, well, I don't even think, I know it helps students, especially those that struggle a little bit with distributing negatives, to think of these as boxes. So for y2, sorry about that, y2, I would have -1 in this box. And for y1, I would have -4 in this box. If you don't use the box approach, sometimes this -4 can kind of look like that negative, and we could combine those and just make this -1 minus 4, which is incorrect. So I think this making the distinction with boxes helps some students. In terms of the denominator, x2 is -6 minus x1, which is +2. So here I have -1 minus a -4, which is -1 plus 4, which is 3. And down here I have -6 minus 2, which is -8. So the slope would be -3/8. The next question asks, does the point 310 fall on the line of y equal 2x plus 4? That's equivalently asking, if I put 3 in the model, does it equal the y value of 10? Well, if it does, then it's on the line. If it doesn't, it's not on the line. So inserting 3, I get 3 times 2 is 6 plus 4, which equals 10, so the point is on the line. The slope will always be the number with the independent variable, usually x, but in the regression context, this could be a name of a variable. So regardless, if there's stuff there, the number that goes with it is the slope. The number that kind of sits by itself with no variable, no x or z or whatever it may be, is our y-intercept. Now, we'll tell you in this problem that this graph is going to be different than it is on the document that's been posted. So let's roll with this. Keeping in mind that another way of looking at the slope compared to this way, when we have 2 points, is just to look at the difference of the rise over the run. The rise is the vertical change, the run is the horizontal change. So the way we pull this off is we start at 1 point, and in this case I would start at this point, and my vertical move is a -4, as noted by that right there. And my horizontal move is a +5 because I'm moving to the right. I'm moving down negative. I'm moving to the right positive. So I have a -4 over +5, which will give me a slope of -4/5. Now, if I started at this point, some people say, well, I need to go this way. Now we need to do the rise first, right? We need to do the up and down. So if I go here, I go up, which is a positive move, +4. And then if I go from here over, that's a negative move. I go over -5 units. So again, I have the same answer of a slope of -4/5. Now, in the graph above, approximate the value of y when x is equal to 4. So that's equivalent to coming in to x equal 4 and coming up to the line and coming over to the axis. So it's approximately 1. And for x equal -2, I come up to the line, come over to approximately 6, maybe a little bit below 6, maybe like 5.8 or something like that. But it's awful, very, very close to y equals 6. On the second page, when we get into regression, it's important that we can make a distinction between the independent and dependent variables. In the form y equals, a lot of times we'll use b1 plus times x plus b0. Again, this is the slope, this is the intercept. The variable that goes with the slope is the independent variable. The variable that goes to the left usually is the dependent variable. So in this case, first year GPA is going to be our dependent variable, and ACT will be our independent variable. And you know, something is critical, key, and as simple as this can often determine whether or not you get your model correct. Because if we run a model, so we're going to have first year GP and ACT in, like, you know, a data set, and we have to tell technology, for us it'll be StatCrunch, which one of these is the X and which one is the Y. Well, if we get these reversed, we get the wrong coefficients, we get the wrong model. So it's important that we can distinguish, determine which is the independent and which is the dependent. Now, the next thing we run into is we have a table of values, and we want to write the equation of the line, assuming it's linear. So it appears to be linear. Now, why do I say that it appears to be linear? Well, it appears to be linear because when I go up 1 unit, notice I go up 7 units for the y. As I go up 1 unit, I go up 7 units to the y. But then as I go up 1 unit, I don't have a value for 3. So I need to make sure that when I go from 3 to 4 up to 5, which is the final value I have, that I land on 7. So what I do is I fill in the missing 3 and 4, and I go up 7 and up 7 again and up 7 again, up 7 again and 7 again. I land on 49, which tells me that I do have a linear function. Now, slope by definition, extremely important here, tells me as x increases 1 unit, the slope is the change in the y value. As x goes up 1 unit, the slope is the change in the y. As x goes up 1 unit, the slope is the change in the y. So my slope is 7. Again, that's the definition of slope. As x increases 1 unit, the slope is the change in the y unit. The y-intercept is the value of y when x is equal to 0. So I have tunnel vision on this data pair, which is formally written 0, 14. So again, definition of a y-intercept, it's the value of y when x is equal to 0. So in this table, the value of y when x is equal to 0 is 14. So I could write the equation by y equals the slope times the independent variable plus the intercept. I hope this helped. I hope this jogged the memory of stuff that material that I'm pretty sure you've learned previously. If you need more work, there's all kinds of stuff floating around the internet through Khan Academy and YouTube videos that can give you maybe a deeper, more thorough, more fundamental, basic review of linear functions. There's a lot of good stuff out there. So, but I think if you've seen this previously, and when you learned it, you had a decent understanding, I think that this review session should have helped tremendously. All right, take care.